right, guys. I think recording last week turned out pretty good. I don't think there were any days that it horribly failed. There were a couple classes. Calc 1. Oh, we did have to start over. But I caught up real quick. Oh. Yeah, you guys didn't miss anything that day. Anyway, there was a bit of chatter going on that was not needing to be recorded. So, can you put this whole class back? Attention. KJ's gone today. And Caitlin's still gone on her family thing. Okay. Can you put this into your calculator? Yes or no?
Yeah.
Yeah. Because there's an ln button. There's ln of, you can do 1 over divided by, there's even an e. Now there's, let's see, there's an e second ln, I think. Is my calculator open? Alright, my little chatterboxes, shush. People need to focus today. There is this little second ln that actually is a little cheat to help us remember that ln goes with e, because if you do second ln, e pops up. So then you'd have to actually type one. I mean, saying how lazy we are, maybe it's not that big a deal. But we could, oh wait, that's just ln of e. But do you guys notice there's also an e over here, second divide? We could just do that, e too. Either way. But sorry, we could plug in this entire thing. Ln of e, square root of e. We can plug it into the calculator and go, go, go. So I can get back to the notes. But I said without a calculator. So quick review of stuff that we saw last week. Who is ln, first of all? Log base e. So he's a log who has a base of e. And what does any logarithm answer? Yeah, any log is looking for what exponent of the base. And the base in this one is e. Now, if you had a log base 10 or a log base 7 or a log base 2, this would change. Exponent of 2 or exponent of 7. Today, I was just starting, let's see, logarithms with HPrecalc. And as I started logarithms with HPrecalc, we had this example that you guys already saw, log base 2 of 32, which they were supposed to go figure out how to use their calculator to do this. But you understand logarithms if your brain could jump to 5. Now, they said Mr. Che taught you guys all the powers of 2, so that you should have had this memorized. I, to be honest, would have broken 32 down and saying oh, he's 8 and 4, and he's 2 and 4, and he's 2 and 2. This is how I learned to break numbers down, either in my head or on paper, to figure out who 32 is, and 32 is 2 to the power of 5. Any logarithm is answering for whatever number is in the base. What power of that base is this argument? The answer is 5. So that was an old example. That was from last week's example. That was first how to learn how to use your calculator, which can you guys remind me where that funny base is of anything other than ln or common? Math and, yeah. So we would have had to go to math, and then I think there's an actual, is it called log base? So we could have typed in, and we could have done log base 2. Oh, wrong one. 32, we would have gotten 5. And then we would have gone over. But remember what you're answering. Any logarithm is saying, what power of 2 is 32? 5. But the nice thing is, mathematically speaking, well, never mind. I was about to teach you what I taught HPrecalc today, but I've already taught you. It's just been a little while. In math, we don't just want to have tricks. We want to have actual ways to solve. And so one thing that we saw last week was a property of logarithms that any time you have log with a base of an exponential with the same base, we can always, in a sense, cancel out and get down to that exponent. So if we can make whatever is in here match, we can just cancel the whole thing out and say, sweet, done. So, what can we do over here? Did anybody think of rewriting this, knowing that we were looking for a single exponent of e? root 2e to the negative, not 1, half. Why half? Al, do you remember that square root is a half power?
Yes.
Okay, because if not, this whole problem would be impossible.
Yay.
A square root, remember, we can take whatever exponent is under the square root and take whatever kind of root, and we can make a fractional exponent out of it. And we can bring it up out of the denominator by using a negative. So negative brings it up. The 1/2 takes away the root. And what was the whole purpose of doing that? Well, who is ln? Log base ln's and e's are inverses of each other. They cancel each other out. Here's what I wanted to show you, and now it actually could make sense. When you're looking at your calculator, remember how I said ln, there's a little cheat, there's an e right above? Log, there's a little cheat, there's a 10 above. ln is log base e. Common log is log base 10. Not only does it tell us what base these guys are, but it also tells us, guys, who's the button right above the log button? The squared button. What's right above the squared?
The root.
What's their relationship to each other?
They're inverses.
They're inverses. The square root of a squared cancels, and the squared of a square root cancels, right? So guess what log and 10 to the power does? Cancels. Or 10 to the power of log cancels. How about ln of e? Cancels. How about e to the ln? Cancels. So it's kind of cool. The same way square root and squared cancel, I can do the same thing with logs and ln's in this example. What happens when I have an ln of an e? Cancels out. Technically, I guess we should say undoes or reduces, but still, I'm left with negative 1/2, which is what you would have done if you had plugged into your calculator. ln of 1 divided by square root of, where is it? Division, right? E. Done. Kinda?
Big brain time.
So if this chapter is about eventually getting to equations that have logarithmic stuff and exponential stuff, we need to know how to undo the log. So something I showed pre-cal today. Ready? You don't have to write it down. Pencils down, just don't stress. I'll give you something like log base 2 of 3x plus 1 equals 4. Do you know how, if I had shown this, or if I showed this today to my Algebra 1B class, they haven't even learned factoring yet.
They're boomers.
They've learned formula. Go team. Exponential, well anyway, stop. They don't know as much as you do. Even though some days it's overwhelming to be in this class. If I wrote this up for them, what do you think they would know that was right? No. They've never even seen a log.
No, I know.
What would they know to do that's right?
They try to bring the 3x plus 1 over to the other side.
Okay, they would be thinking subtracting and dividing, because what do they know you're supposed to get at the very end? Okay, so they know to get x by itself, hopefully. Most of them. They know to get x by itself. But what don't they? So what do you think most of them, and to be honest, some of us still today might do to try to get rid of this?
Cancel with the 4.
They'd be like, what's a log? How do I divide it? They would totally think of dividing. Because it makes sense in their heads. Why does it make sense? Yeah, right? Because doesn't it look like times? If there was a pi, you would divide. If there was an e, you would divide. If there was a 7, you would divide. If there's a log base 2, you divide. No, you don't. Why don't you divide?
Because it's long.
It's not multiplying. It's not log times. It's log of. Here's where your calculator is dangerous. Your calculator says LOG, but technically if you hit the button, it doesn't just say LOG. What else does it say when you hit it? Of. It says, no, I need something. If you try to hit enter right now, does it mean anything by itself?
No. It's not right.
The same way that if I was to hit a square root, and I was to say, go please, oh, I'm not supposed to be y equals, let's get into. If I was to hit square root, is it going to understand? No, because you need an of, you need an underneath. Guess what other people sometimes do? Now, this isn't as common, but it's the same mistake. What if I was to show something like separate problem? Square root of x plus 1 is equal to 30. Doing this, trying that, is just as illegal as trying this.
That boomer.
Oh.
How do I do? You don't.
You have to square the other
Exactly.
side.
We know to get rid of square roots, you have to do the inverse operation, right? That's the legal way to get rid of a square root, not dividing, that's not times, that's square root of. So guess what I need you to know for logarithms?
The same idea.
It's not log times,
Log square.
it's log of. And we have to know, how do we undo a log? Well, if worst comes to worst, kiddos, look at your calculator. The inverse of square root is squared. The inverse of log is 10 to the power of? No, not in this one. What would this one be? Not 10 to the power of, but 2 to the power of. So if we raise 2 to the power of, 2 to the power of, once upon a time you didn't know to square both sides either. Calm down. 2 to the power of, 2 to the power of, guess what we get? Legal canceling out of the logarithm, 3x plus 1 is equal to 2 to the power of 4. Which? 2 squared is 4, 2 squared is 4, 4 squared is 16.
Still can't do that.
So that's subtract 1, 15 divided by 3, x is yes, you can. I just don't like it that way because I want you to see the math. Why? Because there's something coming in a chapter or two that might look like this. Actually, that's impossible. So
I don't like sin.
Let's say.
Sin is against God. Let's not do it.
Good thing it's not sin, unless you make it. What? It's not sin unless you make it sin. Wait.
God is in my
Wait.
How is it sign? There's no E.
Wait. If you start doing this, guess what you start making it? Sin, because you're writing down sin. But guess what it's not? It's not sin. It's sine of x. That's been shortened to be S-I-N. S-I-N-E is its full name. S-I-N is its shortcut. Cosine is the full name. C-O-S is a shortcut. Tangent is the full name. Tan is a shortcut. Logarithm is the full name. Log is the shortcut. If you try to divide by sin, you're going to have some issues. But if you think of him as sine, well, we'll have to learn how to do an inverse of this. Don't worry, it's not today, it's not even
sin
this
will
chapter.
burn.
But we do have another example.
Is fine.
Pause. Is this ln times or ln of? Now, wait. There's no equals, so can we just get rid of the ln? No, we can't just ignore him. If there was an equals, our life would be so much easier. We would just do what to the power of both sides?
E.
Because e is the inverse of ln, because ln has a base of e. But sadly, we don't have another sign, so we actually can't just get rid of the ln. Not this time, but guys, look at the directions. It doesn't say solve, does it?
Expand.
Expand.
That works.
So, just real quick, for those that were gone last week, quite a few were gone on Friday. Caitlin's, I think she's watching the videos. I've heard from her a couple times. But the rest of you guys, there were two things that we learned on Friday. Expanding and condensing. Expanding and condensing. Those formulas, those properties that some of you guys took a picture of, and I showed you earlier. There was a single side and a separate side. And, well, LNs are logs too, so they have the exact same properties, the single and the separate side. The single, everything's being condensed into a single log. The separate, everything's being expanded into separate logs. The single, the arguments getting all condensed together, so complicated. The separate, the arguments are getting simpler, but you're having more pieces. Anyway, we had some arguments, some examples over here of taking a single and breaking him apart into his pieces with simpler arguments. More pieces, but simpler arguments. Or we had ones that were all spread out, trying to bring them all together, kind of like under a common flag, a common log. And basically, I told all of you guys, just trust me. Sometimes it's better to do this. We'll learn, we'll see. And sometimes it's better to do that. It's just one of those, it's a fact of life sort of thing that we have to just hang in there without totally knowing everything. So for right now, in this homework, section 3.3, sometimes you're going to see the direction condense. Sometimes you're going to see the direction expand. And that's just because they're trying to have you practice this skill. So what are we doing in this one? Bringing it all in or spreading it all out? Good. So what do you see that we can start breaking it down with? But there would need to be more than that. So Sophia, what property are you thinking of? Yeah. Anytime you see division under a single logarithm, you can make it separate logs of subtracting, but what goes into each ln?
6 is first.
6 is first because it's the numerator, and what always goes second?
The denom.
The bottom, except, why am I going to erase the square root and write it as what power?
1/2.
A half power.
You can bring it to the front.
Because there's another property of logarithms that says if you have an argument raised to a power, the power can come down. So to make the arguments as simple as possible, well, 6 is kind of as basic as they come, so that's good. And then this was with a square root. Ew, gross. Bring the 1/2 in front, and now the argument is just an x squared plus 1.
Can we take that?
What mistake? There are 2 mistakes. Alec, what were you about to ask?
Oh, like if we could take the square out.
It's a good idea. Except I can only do my property if the entire argument is to a power, which the 1/2 worked, but what doesn't work here?
The square.
Now, can I split up the addition?
Yes.
No! Look at your property!
Parentheses.
I can expand into addition, but I cannot. Hold on. Hello? With the argument, with addition, check out the properties. With the properties, there's only addition or subtraction of separate, multiplication, division of sequence.
Bye, Claire. Don't die.
There's a chem quiz tomorrow, by the way. We do?
Is that for Claire or is that for
Just the math. Well, it's for Claire because she won't be there.
That's explanation. Hey guys, can we go any further then?
No, that's it.
You saw what I meant though, right? By looking at the properties. Was there any single log addition properties? I'm going back real fast. Are there any single log additions?
Sing along.
No. The additions are always with separate. I can only rewrite separate addition, not single addition. So therefore, what's that? But the dilemma is, and if I were you, and if you write things with colored pens, etc., I'm just adding in random pages. Please make a note because it's a very common mistake for kiddos to see the addition and to try to do something when they can't. Box this final answer and say you cannot go any farther. That's as simple as you can go. We'll pretend I was trying to get nice. Okay, so Thursday. No, we did this all on Friday, didn't we, guys? Is that true? I think we did it all on Friday. We talked about the basic properties of logarithms and how to expand, pull apart, and how to condense, how to put together. And we got these basic quotient, power, and product properties together. I think besides that, that was the end of section 3.3. Now, guys, that's the only homework due tomorrow. Okay? Section 3.3 is the only homework due tomorrow because section 3.4 is putting a lot of things together. We're going to need to practice it today and tomorrow, and we'll see, maybe even Wednesday too. But especially for my ones that had to miss a few days last week or got behind, the nice thing is if you can figure out 3.3 and 3.4, I bet going back to 3.1 and 3.2 will be easy because you're kind of seeing a little bit farther down the line. So the nice thing is, kiddos, we're going to keep going in our notes. But there's not really going to be a lot of new stuff you're going to see. We're just going to kind of expand your abilities to how to tackle harder problems. I don't know. More complicated complicated problems, but check it out. Ever since section 3.1. Ever since section 3.1, we saw the one-to-one properties of logs and exponentials make life real easy sometimes. Because the top one says make bases match, right? If we can make the bases match of an exponential, we can ignore the bases and just go for the answers. If we can make the bases match, life is golden for solving. But then we also saw the exact same thing was true with logarithms. If we can make the bases match, we can ignore the logs. But then when we started learning more about logarithms and more about exponentials, we're like, not only can we solve if we can make the bases match, but we can also undo. And that's the point as far as the math behind it. So, Emily, when you were like, yeah, you can just rewrite, it's true, but not every problem can be solved just by rewriting from log to exponential or vice versa. So that's why I make a point of being like, hey, but how do you actually get rid of the log? Not just like a trick to make it disappear.
Make bases match.
Well, that was like the beginning, make bases match. Because if you can make bases match, you get to ignore the A's or ignore the log base A's, which makes everything better. But down underneath is how to actually get rid of. If you have a to the power of log base A, let me make the marker a little bit thinner because I don't want to cover up the important stuff. But if you can do a to the power of log base A, those cancel and you're left with x. Or log base A of a to the power of those cancel and you're left with x. That's how to actually undo legally. Dividing by log makes no sense. But raising a to the power of a logarithm makes total sense. Dividing by the a to the power of makes no sense, but log base a of a to the power of makes total sense. If you understand their inverses of each other. So this is the only legal way to, I'm going to put it in quotes because it's technically not proper terminology, cancel out a log or a to the power. Huh? Way. The only legal way to cancel out a log. So not by dividing, but by undoing. And the only way to undo is the inverse. Now, technically, we've seen these. We just haven't summarized them all into one statement. We just haven't like written them in one page. We kind of built up together. So in a way, guys, this is 3.1, part 1, 3.2, part 1, and 3.3. 3 sections kind of on one page. The things that are missing from 3.1 are the graphs. Things that are missing from 3.2 are the graphs. And then some of those like quotient, product, power properties from 3.3. But this has a little bit of every single section we've covered so far. So let's see what we're going to do with it. Can you guys still see if I do the whole dual page thing? Let me see if it's too small. I can make these problems a little bit bigger, I think. We have some basic equations, which is where this section starts. The beginning of chapter 3, I said it's baby puzzles, but you have to learn the rules to be able to play. The goal, solve for x. Always has been. Kind of always will be. But how do we legally do that?
Log bases.
Yeah. Unless there was an easier way. But yeah, log base 2, it would work. It would undo the 2 to the power of. Unless there is an easier way. What comes before the undoing? What's this? Make a match. Yeah, the one-to-one idea. So hold on. Before undoing, is there a way to make the bases match? Does 32 break down into powers of 2?
Oh, yeah, you're right.
Do you see it? I did it a second ago. Maybe some of you tracked, maybe some of you didn't. If we break down 32, do you remember what it became? As soon as we make the bases match, man, life's easy.
I went the extra mile.
Yeah, you did.
Like the log thingy.
But it would work eventually. It would just take longer to get there, right?
Yeah.
The log base 2 would get rid of the 2, but hey, if I can make the bases match, life is good.
Oh.
Don't hurt yourself. So how about letter B? How about letter B? My formula, people, you could get there, but it would take you a while. My more just natural mathematical sense, can you see what x has to be?
3.
Why? Could it be?
Because 3 minus 3 is just 0.
Oops. Well, not 3 minus 3. ln of 3 minus ln of 3 is 0.
Yeah.
Yeah, you see it? Careful how you say it. ln of x, couldn't I move ln of 3 on the other side, and now what's true? Do they match? Yeah, the same way the bases match, the log bases match. Hey, x equals 3. I'm done. The other way would have been to try to get rid of ln by raising e to the power of, and some of you would have tried to do e to the power of right here. Let's just say, long story short, it would have worked. It just would have been a little bit nasty. It would have worked, it just would have been a little bit nasty. So long story short, if you can use these, oh please do, because look, haha, done, haha, done, right? Ooh, what about letter C though? I guess we could do log base 1/3. Oh, that just sounds awful, right? So I can rewrite 1/3 to be 3 to the power of?
3 to the power of negative.
Of negative, yeah. If I want to bring a denominator up, I have to introduce a negative exponent. So I can do 3 to the negative 1 to the x, which is 3 to the negative x. And then can't I make 9 into 3 to the power of
2?
So remember, negatives can come, or fractions can come up if I introduce a negative. And then bigger numbers can be broken down. And all of that was for the purpose of, they match again. X is equal to. Let me zoom in on, can you guys still see? Are we okay? Yeah. I like being able to point over at the properties. But then everything gets a little bit harder, because check it. Can I make E and 7 match? For those who don't know yet, E is like 2.71828. There's no way that E to any ninth power is 7.
Now you need the log thingy, right?
But I want the bases to match, but we can't. So, I like that Alec is saying the log thingy, but which log do I need? I need the log with the same base, right? So which log has a base of E?
The ln.
So do ln of both sides. The question isn't so much, is it nice? The question is, can you solve for x? But yeah, we could throw in ln of 7 into our calculator. We would see e to what power is 7? Well, e to the 1.9459. E to the little bit less than 2. I guess that makes sense. E is a little bit less than 3. 3 squared is 9. So it has to be a little bit lower. But that was undoing an exponential using a log. What are we going to have to undo in letter F? We have to undo the log. Good. Let's. We have to undo the log using the. I need to.